IrisLogic's YouTube channel. Before we delve into the importance of standardizing tool usage, let's first grasp the concept of platform engineering. Platform engineering serves as the bedrock of modern software development, encompassing the creation and maintenance of foundational infrastructure and tools necessary for developers to efficiently build, deploy, and run applications. Now, transitioning to our main topic is the significance of standardizing tool usage in platform engineering. Imagine a scenario where 10 different teams employ 10 distinct continuous integration or continuous deployment solutions. This diversity can lead to inefficiencies and complexities in the development process. Here's where platform engineers step in to establish a unified CI or CD offering that all teams can leverage, fostering a consistent and streamlined workflow. Similarly, if each team employs Kubernetes in varying ways, platform engineers intervene to standardize Kubernetes usage, ensuring consistency and reliability across the organization. Essentially, they harmonize everything constituting the non-functional requirements of applications. Now, what precisely are these non-functional requirements? They encompass everything essential for delivering the application to end users, excluding the core business logic. This includes fundamental components such as a version control system, a CI or CD pipeline, a runtime environment like Kubernetes, underlying infrastructure such as AWS or other cloud platforms, as well as logging, monitoring, and security measures. As evident, setting up these elements correctly is paramount for smooth application operation. However, each category entails a plethora of tools and technologies, adding complexity to the equation. This is where platform engineers come into play. They standardize the usage of tools providing these essential services, ensuring consistency, compatibility, and efficiency across teams. But does this mean platform teams shoulder the entire responsibility for these tasks? Not exactly. While they play a significant role in setting up and managing these foundational components, their primary focus is on standardizing tool usage and offering support and guidance to teams. So, do platform engineers create Kubernetes clusters and configure them? Yes, they do. Do they design and manage the entire CI or CD pipeline for all teams? Absolutely. However, their role extends beyond mere setup. They also operate and optimize these tools to ensure seamless operations for development teams. In essence, platform engineering serves as the backbone of application development, guaranteeing a unified, efficient, and reliable infrastructure that empowers teams to focus on delivering value to end users without being bogged down by operational complexities. Now, you might be wondering, do platform and product teams share the responsibility for these services? And if so, where do we draw the line between those responsibilities? This is where things get intriguing, and it underscores why I mentioned earlier that platform engineering only works if implemented correctly. Therefore, it's crucial for organizations to invest time and effort into implementing platform engineering practices effectively, fostering collaboration, clarity, and accountability between platform and product teams. When done right, platform engineering becomes a catalyst for innovation, agility, and success in application development. Now, let's delve deeper into what platform engineering is truly responsible for, particularly when it comes to the tools essential for applications. Think of tools like GitLab, Kubernetes, Jenkins, cloud platforms, and databases. Each of these tools has two sides, the admin side and the user side. On the admin side, individuals set up and configure the tool, ensure backups are in place, secure access, install necessary plugins, and perform all tasks required to make the tool ready for its intended purpose. For instance, setting up a Kubernetes cluster involves provisioning, configuring network plugins, establishing access permissions for security, configuring load balancers, and more. Once the admins prepare the tools, users can then utilize them for their intended purposes. For example, application developers access Jenkins to create pipelines for their applications. Essentially, there's a role that operates and manages the tool and another role that utilizes it. These responsibilities can be easily separated. Now, in DevOps teams, both of these responsibilities often reside within one self-sufficient team. This setup allows individual application teams to decide how to operate and use the tools. However, it's important to note that these are two distinct skill sets, each requiring its own knowledge base. For instance, there are separate Kubernetes certifications for administering the cluster and deploying into it. To standardize the tools across teams, platform engineers need to take over the operational side of these tools. This involves selecting standard tools, setting them up in a uniform manner with production and security best practices. This shift is beneficial for application teams as it relieves them of the operational burden, allowing them to focus on creating business value. For instance, to prepare the current cluster for deployment, several tasks must be completed. These include provisioning the cluster, installing the necessary network plugin, configuring access and permissions to ensure security, setting up a load balancer for the cluster, and addressing various other requirements to ensure the cluster is fully operational and ready for application deployment. Once the administrators have completed these setup tasks and ensured that the tools are prepared for use, users can then utilize the tools for their specific purposes. For example, application developers can access Jenkins and create pipelines tailored to their application's deployment needs. This division of responsibilities allows for efficient and specialized management of the infrastructure, enabling smoother development and deployment processes. In DevOps teams, there are distinct roles for tool operation and tool usage, allowing for clear separation of responsibilities. Previously, these roles were often divided, but now, within self-sufficient DevOps teams, both responsibilities are combined. This setup enables individual application teams to choose how they operate and utilize the tools. However, it's crucial to acknowledge that these roles require different skill sets and knowledge bases. For instance, there are separate Kubernetes certifications for administering the cluster like Kubernetes Administrator Certificate and deploying into the cluster like Kubernetes Application Developer Certificate. This underscores the necessity of learning each aspect of the tool independently. To streamline tool usage across teams, platform engineers must assume responsibility for the operational aspects of these tools. This entails selecting standard tools and configuring them uniformly, adhering to production and security best practices. Indeed, this approach offers significant benefits to application teams by alleviating their burden. With certain services, such as Kubernetes cluster administration, now managed by dedicated platform engineering teams, application developers can focus more on creating business value without the added cognitive load of managing these infrastructural components. This redistribution of expertise allows for more efficient utilization of engineers' skills. Rather than having Kubernetes experts dispersed across multiple teams, a central platform engineering team can handle these responsibilities for all application teams, as well as other tasks like CI or CD tools and database administration. By centralizing these responsibilities, the platform team can dedicate more time and expertise to ensuring these tools are operated effectively and efficiently. This removes the pressure and need for each individual application team to possess expertise in administering these tools, leading to a more streamlined and standardized approach company-wide. The setup ensures consistency and reliability across the organization while still allowing individual application teams flexibility within predefined parameters. This approach maintains the benefits of DevOps integration while optimizing efficiency and standardization. Now that we've established the baseline understanding of platform engineering and the importance of standardizing tool usage, let's address a critical question: how do we standardize without creating silos? In the next video, we'll explore strategies and best practices for standardizing without inadvertently erecting barriers between teams. Stay tuned to learn how to foster a culture of collaboration and innovation within your organization, even as you standardize your development processes.